So in my collection I have three TRS-80 Model 1s. This is by far the most heavily modified one I have. It has a character generator replacement I did here where I can swap in and out various character sets. The dip switch is controlling which character set is enabled. This plugs down into the ROM socket where the character generator ROM originally was. It has the level 1 or level 2 basic adapter board. Again, we looked at this in a couple previous videos. There's a flash ROM on the underside of the board here, and this plugs down into the sockets where the original ROMs were on the system. What we're going to focus on, however, is this Sprinter 1L mod over here. I had a request from one of my subscribers, Pascal, if he could reverse engineer this board. He'd like to produce replicas of the board, potentially to sell, and it sounded like an interesting project to me. So in this video we're going to uninstall this board, and from there I'll decide what I'm going to do. I think I'm going to go ahead and probably remove all the chips on the board and get it down to the bare PCB so we can get some high-res photos and measurements from it. Haven't decided yet if I'll actually send the board off to Pascal or not. I may. Of course, this thing also has on it this mod here, and at the moment I don't remember what this mod is. It completely slips my mind. Is it the... I don't know. I don't remember what that mod is, but anyhow, in this video I wanted to jump in and look at this. I've taken some high-res photos of how it's installed. I do have the Holmes Engineering manual that I used to install it with here. There are some trace cuts that have to be made on the machine. And I'm assuming, I'd have to go back and review the video. I don't recall if I had to make the trace cuts or not. Apologies for the dog coughing in the background. When you adopt elderly dogs, all their health issues come along. But anyhow, let's jump in, uninstall this board, and we'll go from there. So I guess the first thing to do is to get it up out of the socket that the Z80 was in. Let's see if I can just manually get it to come up out of there. And it looks like that's going to be a little tough to do. Let's see if I can get something with some leverage under there. Yeah, that is very tight. Not surprised it's very tight. I don't want to damage the PCB. I am between the Sprinter 2 PCB and the inside of the Z80 socket on the original Model 1 motherboard. Let's just see if we can get that to work its way up out of there. And of course it's going to be very, very difficult. Well, mechanically it was in there very solid. I guess that's a good thing. See, I don't want to pry too hard there. It started to work loose. So we have the board loose, which is a good thing. And I did score the board up right there with the screwdriver. Crud. Tried to avoid doing that, and I still managed to do it. So anyhow, let's go ahead and begin to tear this down. And get the tools prepped here. The first thing I'm going to do is remove this yellow wire. And I'll remove the orange wire. I'm going to keep hitting the trigger accidentally, which I believe is right here. The blue wire, which is right here. And this red wire. You remember in the previous video we got this board installed and actually working. So that gets the board removed. That's very nice. Leaving the wire in here intact to make this easy to reinstall. Let's go ahead and take a little closer look at the board. We did this before. Of course, we've got the Z80 in the socket here. Let's see if I can get him out of the socket. He's very tight down in there. Wow. Without stressing the board too much. Wow, that is really in there. Well, let's see if we can walk along underneath and get it to release. So of course you pull the Z80 out of the Model 1 motherboard. It goes into this socket, and then these 40 pins here push down into the Z80 socket on the Model 1 motherboard, and then of course there's those 4 jumper wires that come off. Hopefully I've got this somewhat up here where you can see it, because I can't see the screen on the camera. I have to stand up to see it. Hopefully we're getting focus here. There's a look at the top of the board and the bottom of the board, and of course there's these 2 resistors that have been added underneath the board. The idea here is to be able to expose the traces underneath the chips to make making a replica of this board easier. And that's really easiest done by removing the chips. So one of the first things I want to do here, see if I can find a piece of paper to write against. So I'm going to draw out a sketch of the board. There's an IC here with pin 1. There's an IC here with pin 1. This is U2. This is U1. There's the hole in the board. There's an IC here. That is U4. There's an IC here, which is U3. And again, pin 1 is this way. There's an IC here, which is U6 with pin 1 that way. Of course, I'll get high-res photos of all of this, but I always like to start with a sketch. U8, pin 1. There's an IC here, which is U7. There's one kind of offset up here, which is U5. And there's a device sitting about here, which is U10. We then, of course, have the Z80 socket, and it looks like pin 1 is right here. There's a white dot. Yeah, that's the orientation the chip came out. And then there's the row of pins here and here that go down to the original socket. And we have a notch in the board. So the next thing I want to do here is capture some part numbers. Easier to flip it over this way. 74 LS 109. 74 LS02. 74 LS30. 74 LS138, and 74 LS123. Then coming around this way, we have a 74 LS74. We have a 74 LS161. We have a 74 LS173. And a 74 LS04. Now walk back through this: 74 LS74, 74 LS161, 74 LS173, 74 LS04, 74 LS123, 74 LS138, 74 LS30, LS02, and a 74 LS109. There's a resistor pack here. I'm just going to add some detail. There's 3 resistors that are kind of offset here. There's a resistor sitting in here. There's a resistor sitting along here. And let's see, the 3 of these are brown, black, red, so they're all 1K. There's a red, or an orange, brown sitting right here, so that's 330 ohm. Be 3 with 1 0. And there's a yellow, purple, yellow, and now I run into trying to remember color codes that high. Anyhow, it's a yellow, purple, yellow, whatever that works out to. These are labeled, so R6. This is R5. This is R3, 2, 1. R3, R2, and R1. 1. We're going to need to figure out where these are on the bottom of the board. We have C5, C4, C3, C2, C5, C5, 4, 3, 2, where's C1? Is there not a C1 on the board? Let's see if I can figure out the value of that resistor pack. I really can't see it down in there. Looks like it might be hard to say. I can't read it well enough. That's a 104, 104, 104, 104. Almost looks like 105, but it's 104. So this is a, did I miss her? C3, so this is a 0.1. This is a 0.1 microfarad. These are just despiking caps, 0.1 and 0.1. On the back side of the board, see if I can look through the board to see that resistor. There's a resistor. There. That is brown, black, red, so it's 1K. There's a resistor. Oh, I see what they've done. There's a resistor hiding here on the back side that actually has a silkscreen for it on the board. And it's another 1K brown, black, red. But you can't really work a part in there because of the size of the sockets. R1, R2, R3, and it's labeled R4. It's on the back. 1K, and it is R4. So the Bodge one down here is interesting. Really doesn't have a silkscreen to it. .1 microfarad to spiking caps. There's one there. Actually, well, C5, C2, C3, C4, C5. There just is no C1. There's not even a silkscreen for it that I can find. It's pretty standard stuff here. It's just standard Jelly Bean TTL logic. Pretty standard value resistors, 1K, 330. Be damned if I can remember what yellow, purple yellow is. That's just not clicking in my brain at the moment. Not super important. You can see maybe here where I knocked some silkscreen off the bottom of the board. This has got pin 1 labeled. That's interesting. That seems backwards. Maybe it doesn't have pin 1 labeled. That's a scratch from the screwdriver. I'm sorry I took that out that way. Didn't mean to damage the board. Now I'm going to pause the camera here. I'm going to shoot a number of photos of the board with it out to get as much detail as I can. And of course I'm using the same camera for the video and the photos, and after I get the photo shot, we'll come back and keep recording. So we've got a bunch of photos taken of the board. And I'm really trying to decide on the best approach to tear this down. It's going to be a little difficult to do. It's got to be done in the right order. The soldering station was recently serviced. Looks to be doing a reasonable job. If I got the wrong tip on here, that tip feels awfully large. Nope, I've got the smaller tip on it. These are just tiny little pads. I'm doing my best here not to score up the board. It's got some bent over pins that they use to hold the socket in place. That one did not release. cold solder joint there. Yeah, these pads for the Z80 socket are tiny, which is why the tip feels so big. If I have to, I'll sacrifice the socket to keep from damaging the PCB. We'll find out when we get there. This one didn't release. Still didn't. Tip's getting really dry here. Got some that just don't want to release, so we'll add some fresh solder to those. We're also going to attempt to straighten up these pins that are bent over. So didn't want to release. There's 3 of them, 4 of them along here. No, that's the wrong tool for the job. Straighten up the pin. Might need to get under that one with an X-Acto blade. If I can find it. Hopefully I don't have my big old head in the way here. Already stood up. Is there any that appear to have not desoldered along there? Still didn't release, so we'll come back around to it rather than try to force it. Those really don't want to be soldered. There was one along here I was unhappy with. So we'll use a little, see, I missed this one a minute ago. A little more dwell time. Alright, cleared. This one again, just because it looks. Thing I like to do is attempt to make sure each pin is floating. Sometimes you kind of have to unsnap them from the via. This is happening here. Either see it move or hear that little click. One here that didn't feel like it released. one's not unsoldered. And the one next to it isn't either. See, I don't mind sacrificing the socket if I have to. It's just a inexpensive double wipe socket. When I reassemble this, I would probably do it with a... Okay, there's one side completely loose. With a nice... somebody down there hasn't released. Guy right there. Oh, that's still full of solder. Where was he? I believe it was that guy and that guy. Apologies for the washing machine behind me. The lab here is operated on very much a shoestring budget. As you know, I don't ask for donations, although they would be much appreciated if somebody wanted to donate. I haven't set up like a GoFundMe or a PayPal, or well, PayPal, or well, it wouldn't be a GoFundMe, a Patreon, or so we got the majority of the pins. A few of them have stayed behind in the board. Not really surprised. Often they'll just come out if you wiggle them a bit, although he's not going to. He seems loose. There he goes. Just took a bit of persuasion. In this case, we did end up sacrificing the socket, but that's okay. Will burn myself here. Yes, I'm using bare fingers. Oop, he's getting hot. He didn't release. There he did. We're down to one pin that's just really being stubborn. We don't want to break the pin off. Okay, I can see the pin wiggling. So why doesn't it want to release? A little dab of fresh solder. So I'm not going to worry about going back and clearing that hole out. But what I wanted to get to is so I could see the resistor pack, and we've gotten there. And it's a 102, so it's a 1K, I believe, times 10 resistor pack. And it's a 10x1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm sure it's pull-up resistors, probably on the data bus. It looks like it is pulling up 10 different pins, and pin 1 is on that end right there. Let's see if I have any luck getting the machine pin sockets out. That might be a little tougher. And that the The plastic carrier is up tight against the PCB, which makes getting airflow under to help desolder more difficult. Again, I don't mind sacrificing it if I have to. Interesting that on these two end pins they've trimmed them very short. I'm assuming to kind of clear something. So I can see a lot of them rocking and a lot not. This guy I don't want to. They're now rocking back and forth. This guy isn't. Trimmed off short there. It's still attached. You might need a little more persuasion. If I can spot the needle nose. I have effectively at this point destroyed the pin header. Like I said, not that I'm worried about it. I just don't want to tear via out. You can see all the pins moving, so. Somebody's still got a really tight grip in there. There may be a bit of solder on the. There we go. Yep, destroyed the pin header, but that's absolutely okay. It can be replaced easy enough. It's a common part. The idea is to get the board down to the point we can get good photographs of the traces all the way around, both sides, and then I believe his name is Pascal, can go ahead and do the artwork and recreate the board. I'm not having a lot of luck up against the resistor pack. The extra thermal mass seems to be being the problem here. Well, some of them have come loose and some haven't. This one's going to be a little bit tougher. I'm not sure why it's being such a little pain, but we'll add some fresh solder and run along the ones that seem problematic again. Sometimes just a little fresh solder, getting a little bit of flux on the board, etc., helps. Maybe power rails. I want as many of them loose as possible. Now this side's really being stubborn. I mean, really being stubborn. It's going to get removed a few pins at a time. I don't want to squeeze too hard there and take a chance on damaging the board. Those are loose. Keep working my way along here. So that block of 3 is loose. Block isn't. Let's see already that. Oops. Extra solder there is going to be a problem on that one pin. If I can get these to kind of flex up out. Don't want to cut too hard. And come on. I'm up against that resistor pack now, making getting up under there rather difficult. Yep, we sacrificed the connector, but that's okay. Do my best to burn myself here again. So I don't want to burn myself this time. Let's see if I can get a grip on him that'll hold. And I can't. Oh, come on, pick up. Well, he broke off. Pin is still on the board. Not a disaster. Really? Really? You're going to clip on there till I need you and then you're going to release? Get a grip on there. Yeah, no surprises here on what we're seeing. I'm not going to get a grip on that pin that's stuck in there. Why won't you hold on? This is going to be a bit tricky. There, the pin is removed. Again, I'm not going to worry about clearing all the holes. Well, that is absolutely one-to-one wiring. Oh, not quite. So there's a gap here, and I'll bet that's the clock pin to the Z80. I don't know that for sure, but I'm going to guess. See with the board this way. This pin up here. So it's 4039, 38. I'm going to guess that's probably the clock pin on the Z80 because it's not tied directly through to the TRS-80 motherboard. So that would be my guess. Because all the other pins are, you know, well, almost all the other pins. There's another one down here that doesn't go all the way down. So that's interesting. These resistor packs can be a real bear to get out. In this case, I really am going to refresh the solder. Just add a little bit of fresh to every connection. Again, if I have to sacrifice it, I will. I'm not concerned about the pack. It's a common resistor pack. Pretty easy, though, I think, to determine the layout of the board, even with it. I have to go back to the one pin I skipped because it was bent. Certainly hasn't got it. I don't think a single pin released. That one's now released. That one is. 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 That one didn't. That one didn't. So the bottom three pins have not released. Some fresh solder. Stand up and take a peek at the camera, make sure we're still recording, and we are. hit those again. I bought a stand for the soldering tool, and it's made it much more convenient to use. I believe that's got all the pins wiggling. It has, so now it's just a matter of pulling it out of there. And we're going to go ahead and measure him quick. I suspect he's bust. Just to make sure it's bust. It has to be bust. It's a set of pull-up resistors, but I'm still going to check just to make absolutely sure. Need to go to ohms. Get a connection to pin 1. Okay, now, was that not pin 1? No, I was on the wrong pin. That's why that looked funny. There's pin 1. I should see, well, if I can maintain a connection, I should see 1K, 1K, 1K. So this tells me it's a bust, that pin 1 is common to all the resistors in the package. And this is just being used as a 1K pull-up, which is exactly what I would have expected based on what I saw on the PCB and where it's being used. So just as expected. So we're making progress. We're a half hour into this video, and with 15 minutes up front, I should close this segment out as the first video, and then we'll do a second video with the final teardown of the board. So I'll see you in the second video. We'll talk soon.